Hello, this is Nas from NB Lessons. Hope you all are doing well. Today I am going to shift gears and I'm going to go ahead and start teaching algebra. Besides, I've been teaching you guys about networking, computer networking. I've gone over various subjects like, for example, I've gone over VLANs, ARP, OSPF routing protocol, BGP routing protocol, static routes, IP packet, Ethernet frame, and so forth. So I'm going to go ahead and switch gear today, and I'm going to get into algebra, pre-algebra. Anybody in high school can take advantage of it, or anybody who wants to learn algebra and progress in that area can take advantage of that. So without further ado, let's go ahead and get started. So this is pre-algebra. It's going to be course number 1. So let's go ahead and go over real numbers. A lot of you might already know, but let's assume that there are folks out there who are still wanting to learn. So real number, what is a real number? Let's go ahead and draw this graph. You have y-axis and you have x-axis, right? X is the horizontal, y-axis the vertical. If you can plot a number on x-axis or y-axis, that is a real number. For example, 1, 2, 3, 4, -1, -2, -3, all of these are real numbers. 0, which is right here, 0, 1, 2, 3, 4, -1, 2, 3, -4, all of them are real numbers. Even a decimal number, say right here, it's 1.5, that's also a real number. 3.3, that's also a real number. So anything which you can plot on x-axis or y-axis is a real number. You know, you go up right here, y-axis also you can go 1, 2, 3, and so forth. So any number which can reside on a horizontal axis or vertical axis is classified as real numbers. Okay. Next, let's get into what are irrational numbers. As the name sounds, irrational, the numbers are irrational. In other words, they don't have any pattern, and you don't see those numbers in daily life. So let's look at some examples. So for example, pi, okay, pi, which is equal to 3.1459, and it goes on and on and on. So that is basically an irrational number, okay? Because one thing about irrational number is that they are non-repeating, and have infinite decimals. Now, a lot of you know that pi is basically, if you want to write it down in fraction form, is 22/7. However, if you put this in your calculator, you will see never-ending number. And those numbers don't repeat. There is not a pattern. So you see right here, 3.1459. There is no 1459 again, or no numbers like 9, or 5, or anything like that. So non-repetitive numbers, infinite decimals, those are irrational numbers because they're not normal. Another example, square root of 2. What is square root of 2? It's 1.4142, and that goes on and on. Okay? That is not a rational number. They said that is an irrational number. So the numbers which do not have any pattern and they just go on and on and on, like I gave you example of this and this, those are irrational numbers. So keep that in mind. Now we go ahead and get to what are rational numbers. So I'm going to go ahead and erase this. So rational numbers are numbers which can be written as fractions also. Okay, so let's see an example of rational numbers. Okay, so is 0.25 a rational number? Yes, it is a rational number because it can be written in form of a fraction. 1/4 is a rational number. So rational numbers can be written as fractions. 0.25, yes, it is, has a fraction. 0.5, yes, it's 1/2. All right, 3/4, that is 0.75, so that's a fraction. So all of these numbers which can be written in form of fraction are rational numbers. Even 2, let's say number 2, okay, it can be written in form of fraction. I can write it down as 2/1. It's still 2. I can say 6.25. Is that a rational number? Yes, because I can do 6.25 divided by 1 gives me still 6.25. As you know, anything divided by 1, it's the same thing. So rational numbers can be written as fractions. The number which can be written as fractions. So pretty much all numbers are written as fractions. Let's say we look at is 2/3 a rational number? Let's look at it. So if you divide 2 by 3, you get 0.6666, and this number keeps on repeating. This dash on top of 6 demonstrates that this the series of 6 is infinite. So yes, that is a fraction. Let's see, is -7/8 a rational number? Yes, it is. This negative sign has nothing to do with rational numbers. It doesn't matter as long as it can be converted into a fraction form. Your numbers are rational. So I think I'm going to stop right here. I'm going to come back with part 2, where I will talk about integers, real numbers, whole numbers, and so forth. So see you in next topic. Stay tuned. And if you like the content, go ahead and give me a like. Thank you.